All right, going to talk now about our efforts to update the Tri-State Fertilizer Recommendations. Okay, this is going to be the first of three parts, and this one is going to talk specifically about kind of the overview and the framework. Now, I recognize that this is a general soil fertility class, and that some people might not be particularly that interested in agronomic crops. But it's important because, from an Ohio perspective, the tri-states really dominate the way we kind of think, or really help form the way we think about nutrient management. And so um, I'll go ahead and get started with this. Okay, so just a small bit of history. That 25, 30 years ago, ag retailers wanted a consistent recommendation. It made no sense that if you were in Northwest Ohio and you moved either north to Michigan or west to Indiana, you got different fertilizer recommendations. And it's kind of a common problem that happens, but the industry asks for Ohio, Indiana, and Michigan to come together and kind of create some common recs. And so that's what happened. It was released in 1995, and I'd say for the most part it's been widely adopted and relatively well received by the ag community. Okay, so again, 1995 was 25 years ago. The data that went into this manuscript or this PDF publication was really collected from the 60s to the 90s. So maybe 30 years of data, or 40 years of data total. Producers, since I've been here, question its suitability. It's old information. Is this relevant in my high yielding environments, et cetera, et cetera. Okay, so there's really been a call to update. It started really before I arrived in my position here. And there's good justification. Farming, the way we farm has changed quite a bit in the last 20 years. Our yields have increased. The amount of conservation tillage that occurs is greatly increased. Conservation tillage, before 1995 was kind of not something that was done that often, but now it's very very much a widespread practice. Of course, most of that has been enabled by the adoption of Roundup and Bt genetics, so genetically modified organisms and GMOs of sorts to help make this happen. Our rotations are, in other words, the complexity of crop rotations has typically been reduced as we focus more on corn and soybean, as those acres have grown and other acres have shrunk. There's new pests and diseases that have emerged. So there's a whole kind of suite of things that have happened. In tandem to this, there's the social dimension that the majority of Ohio farmland is rented. Majority of acres are actually rented acres at this point, and this is true for most of the Midwest. Small farms, people used to own farms, and they want to keep that land in their family name, or they keep it for whatever reason. They might just rent it out, so what they get for rent can actually pay taxes or pay the bills. But this is a reality in terms of kind of the demographic of what we're dealing with. We've already talked extensively in this class about water quality and water quality issues, putting a spotlight in nutrient management ag. Okay, can we do better as a farming community? Absolutely. Should we do better? Absolutely. So again, this is really a call to update these as an industry-led effort. Fertilizer costs are, next to seed costs, typically the farmer's second largest input expense. So to the extent that we can perhaps reduce fertilizer recommendations or fertilizer use on farm, there's a lot of opportunity to increase the profitability of a farming operation by doing that. Okay, so just providing some justification for this work. What's wrong with the Tri-State Fertilizer Recommendations? Well, I've heard many people gripe to me about a lot of different things. The first one and foremost is based on data from decades ago. it's based on soil test extractants that are rarely used anymore in the commercial soil testing labs. We'll talk about that in just a second. It solely uses the build maintenance approach and oversells the prescription of soil testing. I'd argue this is me saying that this idea, I think it's given a false sense of security or a false sense of confidence in terms of our ability to really predict the behavior of soil testing over time. Okay, so what we've really tried to address, and I'm in a PDF mode here, so my little PowerPoint animation isn't working, so I apologize for that. But we've got plenty of new data. Malic 3 will become our default extractant for soil test P and K. We're going to modify the build-up and maintenance approach. I'll talk about that here just in a bit. And the focus is really going to be more on adaptive nutrient management. So in other words, maybe a little less prescriptive and more, less of us telling farmers what to do, but more about like, here are some tools and here's how you can figure this out. Okay. So moving to Malic 3 extractant. So the original TriState Recommendations, I'm not really going to get into the weeds here, but they're based on two separate extractants, Bray P1 for phosphorus and ammonium acetate for potassium, calcium, or magnesium, i.e. the base cations. Starting in the early 90s, mid-90s, a new extractant, this Malic 3 extractant came out, which was a universal extractant. So the Malic 3 enabled the Bray P and the ammonium acetate you could get information on phosphorus and base cations with one single extractant. So rather than doing two separate extractions for the same information, you just do it one time. It's faster, it's easier, it's cheaper, etc., etc. So this is where the commercial labs moved, regardless of what the university has thought about this. Okay, now I'll say that you go to Kentucky, you go to Pennsylvania, they've been using Malic for a long time, and so commercial labs in those respective states also use Malic. Here we're just really trying to say, okay, like let's be reasonable and use what commercial labs are doing, so we don't have to keep converting back and forth. Okay, we've done a bunch of work. You can go to this web link if you want to get into the details. Go.osu.edu Malic, and it's a published fact sheet talking about the work that we did with this. We collected a bunch of soil samples. Bray and Malic are not the same value. But if you multiply by essentially 1.35, you multiply Bray values by 1.35, you get a Malic equivalent. And so what that means is 15 to 30 Bray ppm is now 20 to 40 Malic. And for ammonium acetate, for potassium, this AA, that's often abbreviated AA for ammonium acetate, there's a little bit more variability here, but typically, our data showed that it was about a 14% difference. Because the numbers are a lot higher, we're basically doing what a lot of other states have done and what commercial labs do, which say that they're roughly the same. So ammonium acetate and Malic 3 potassium are roughly equivalent. Okay, so what we're trying to do here is really just simplify the process and clear up confusion, because there's been a lot, the last, say, 15, 20 years, has been a lot of, yeah, but is that Bray phosphorus, is that Malic phosphorus? So we want to get away from that, just have kind of a single unified extractant. Okay, let's talk about the framework of the existing TriState Fertilizer Recommendations. Again, published in 1995. You basically have fertilizer rate over soil test level. And as soil test level increases, our fertilizer rate generally decreases, okay? We have three separate regions. We have a buildup region, a maintenance region, and a drawdown region. And those are divided by this critical level. This is the point. This is a magic piece here in the equation. And then this maintenance limit. So the maintenance range is bracketed by the critical level and the maintenance limit, okay? Now, we look at the soil test value, and for phosphorus potassium, it's really extractable soil test P and extractable soil test K, that is Mehlich P and Mehlich K, that define when we need to fertilize, how much we need to fertilize, etc. Okay? And so the definitions here is that if you're below the critical level, you are deficient. That is, a yield response to fertilizer is more likely. If you're above the critical level to the drawdown, you're sufficient. That means if we apply fertilizer, we are not expecting to see a yield response, okay? So we expect that it's just going to be to maintain your soil test level. Above that drawdown range, it's called excessive in the TriState recommendations. That means there's no agronomic reason to apply. Okay, so what does this mean? In terms of rates, it means that when you're in the maintenance range, this is really where the recommendations want you to be. This is the optimal range, this maintenance. And when you're there, the fertilizer rate is going to approximate crop removal. So in other words, if you are pulling off, say, whatever your harvested product is, if it's corn grain or soybean or alfalfa, if you're pulling off 100 pounds or 50 pounds of P2O5 phosphorus, that's going to be the fertilizer recommended rate. When you're in buildup, your soil test levels are low, and we say we want to actually apply what we're removing with crop removal plus some extra, because we want some extra fertilizer to take our soil test levels up. We need to raise them up, and so that's what this like extra piece. So when we say build up, it means that we're in this range where we're trying to apply more fertilizer than we need, and so that's going to build the soil test levels up a little bit higher. And then when we get to above this maintenance limit, it's in this drawdown range. And this drawdown range basically says we're going to apply a little bit, not crop removal, but a little bit less than crop removal, and then it quickly goes to essentially zero, where your fertilizer rate hits this excessive. So this is the old framework, okay? And we're going to be doing things just to kind of simplify this. That's really our entire goal, is to simplify some of this, okay? So the new framework looks very similar. We've got this fertilizer rate by soil test level. We've got a critical level and a maintenance limit, okay? Notice that there's not a drawdown range here. And we can say that maintenance across the entire soil test range is really basic crop removal. So anything from a soil test value of 0 up to your maintenance limit would be crop removal. Here, again, we're just tightening the kind of range in terms of what we would call sufficient to excessive. So we're eliminating that drawdown and bringing this excessive range back a little bit. And then we're saying that this buildup range is optional but recommended, okay? So the two real changes are we're getting rid of this drawdown range altogether because we don't believe we need it. We believe it adds unneeded complexity, and that we have greater confidence in soil testing now than we ever have. And then we are making this build-up range optional but recommended because we understand that we're just trying to give farmers a little bit more flexibility in terms of how they manage their operation. So this is essentially what I just said. Why change the framework? Simplify our recommendations. As soil sampling densities have increased, as quality control in commercial testing labs has gone up, the uncertainty of soil testing has decreased, right? So we have better sense of what our fields actually look like in terms of available nutrients. Majority of cropland in the region is rented, and so if a farmer's not sure, and so just to flesh this out a little bit more, that basically means that it might be a year-to-year land contract, it might be every 3 years, But if a grower is not sure if they're going to be farming that field in 2 or 3 years from now, they might not be particularly interested in investing a lot of money to build up those soil test levels. So it gets into the kind of the economics of buildup, right? And so again, it's all in the vein of providing farmers with some more options and more flexibility. Okay. So we talked about the 4 R's, right? About rate, timing, source, and placement. In other words, how much to apply, when to apply, the type to apply, and the broadcaster band. Now, these recommendations really focus on 2 things. They focus on rate and they focus on timing. The source, say for P or K, we don't think is particularly that important. And placement options will dictate a lot of things and are just complicated enough that it's really hard to kind of integrate into this framework. So a lot of this is based on broadcast applications, and we're going to focus these recommendations, or the recommendations are focused on rate and timing. How much to apply and when do you need to apply, okay? So the fertilizer rate, again, is based on maintenance. And so when we have 40 bushels of soybeans that we harvest from a field, we're typically going to pull off something like 62 pounds of P2O5, that's phosphorus. If that yield increases to 60 bushels, then that goes from 32 pounds to 47 pounds. So in other words, yield, the yield of a field strongly dictates its crop removal rate. Okay, so in a 60 bushel soybean field, our fertilizer rate is going to increase. Okay, again, the animation here is turned off because it's a PDF. So you can imagine, this fertilizer rate, this bar here, increasing up to 60 to accommodate for that removal. The second piece is when to apply. Okay, and so when it's deficient, we say, apply now. Do not grow a crop without applying fertilizer because you're in risk of losing yield. Okay, so it's still very conservative. It's not guaranteed that if you don't apply fertilizer, you're gonna have some kind of yield loss. But when we're sufficient, we say apply sometime within that crop rotation. It doesn't have to be now, this year or next year, but sometime within a 3 or 4 year rotation, apply. When we're excessive, the recommendation is just do not fertilize. Okay, so as simple as that. All right, so this is really kind of the new framework that we're dealing with. Okay.